Okay, so in the previous video, we talked about the law of cosines, an introduction of the law of cosines. Now we are going to apply those ones in solving certain examples. So let's take a look at first the formulas for the law of cosines. So if you're going to look at this, we have the standard form and the alternative form. I told you if you will be able to memorize one, you will be able to know this one as long as you have to remember the pattern. One formula and then remember the pattern. If that is A, then that would be angle A. If that is B, that is angle B. If you don't want to use these types of formula, then you just use this formula and then just manipulate it at the end. Okay. Now let's take a look at some examples. In the law of cosines is only applied in two situations, in two conditions. That is, if a side is given, an angle and a side. Remember that the angle again is given between two sides. Okay, and then the other condition is that is supposed to be three sides are given in a triangle. If three sides are given in a triangle, then we can use the law of cosines. However, we start with this first, SAS. Example, solve for side A in triangle ABC given A is equal to 42.3, B is 12.9 meters, and C is equal to 15.4 meters. The first that we're going to do again is to identify the sides of the triangle, label the sides of the triangle. Okay, we have to label it correctly. Again, if you're going to look at this, we have A here. However, if you place A here, it doesn't matter as long as you are consistent in identifying the sides. Now, in this case, A is here, B, angle B, and angle C. Now, if angle A is there, then this is side A. B, that is side B. C, side C. So we write the given. Angle A is 42.3 degrees. Side B is 12.9 meters. And C is 15.4 meters. Again, if you remember the formula here, we are trying to solve for A. If you remember the formula, if that is A squared, then in here we place immediately cosine of angle A. The remaining sides of the triangle, that would be B squared plus C squared minus 2BC. After that, we just have to substitute the values in our formula. So, if you're going to look at this, that is A squared is equal to B squared plus C squared minus 2BC cosine A. Substitute the values. We have B is 12.9, C 15.4, and then we have the angle at 42.3. Using your calculator, if we're going to solve this, then we have A squared is equal to 109.7. However, we are supposed to solve for A, side A. So, we get the square root of both sides, giving us A is equal to 10.47 meters. Remember, if we get A squared or we get the square root of this, we have positive and negative. But we are talking about distance and we don't have a negative distance. Therefore, we always have a positive value. We always take the positive value. Now, the next condition, if three sides of a triangle is given, the SSS. Example, solve C in triangle ABC if A is equal to 9.47 feet, B is 15.9, and C is 21.1 feet. Again, if we're going to have this, say for example, this triangle, we label the sides. A is there, B, C. So A, B, C. Again, next, we identify the sides. So if A is here, then this is side A, which is 9.47. Angle B, therefore opposite, that is side B, which is 15.9. Angle C, that would be 21.1 feet, the side C. So what is being asked in the problem? That is, we are going to solve for angle C. So again, if that is angle C, that is side C, we have C squared is equal to, that is cosine C. So that would be A squared plus B squared minus 2AB. Or we have this. So C squared is equal to A squared plus B squared minus 2AB cosine C. In this example, I will be using the this formula. However, again, if you don't want to use that formula, you can just do this. You can just substitute the values here and then manipulate at the end the value of cosine C. Now, in this one, cosine C is equal to a squared plus b squared minus c squared over 2ab. I am now ready to substitute the values. So that is, a is 9.47, b is 15.9, and c is 21.1 over 2, 9 times 9.47 times 15.9, giving us cosine C is equal to negative 0.341. We may have these three decimal numbers. How do we solve for the value of C then, the angle C? So that would give you now C cosine inverse of cosine, that is 0.31341, giving us an answer of 109.9 degrees. I have another example. A road makes a bend to y so that xyz is equal to 130 degrees. There's a short path. This is a short path, x to z. This is a short path. If xy is 100 meters, yz is 80 meters, what distance is saved by walking along the path instead of going around the road? So what is being asked here? If you're going to look at this x, y, z, what about if you're going to walk from x going directly to z? Okay? How shorter would it be? How much shorter would it be? So if you're going to have this, let's identify the sides first again. So if that is y, then this would be, this would be side, wait. This would be side y. This is x. This would be side x. Z. This would be side z. If you're going to look at this, we're going to solve for the path first. How far is x to z? And that is y. So that would be xz is equal to the other sides of the triangle. That would be this side and this side. X z squared. Xy. That would be xy squared plus this other side yz squared I will have that. And that would be minus 2 xy yz cosine y. So we have this. Now we are ready to substitute the values. Remember, we're trying to solve for x, z. We substitute the values. Xy is given by 10. So 10 squared plus, that is 80. 80 squared minus 2 times 10 times 80. And then again, that is cosine 130 degrees. So that would give us, oh, sorry. There is a problem with this. This is supposed to be 100 meters. That is impossible. That is 10 meters. So that is supposed to be 100 meters. Say that is 100 meters. So that would give us square 100. That would give us, okay, that is 10,000 plus 6,400 minus 2 times 10 times 80. That would give us 16,000. Okay, cosine 130. If you do that with your calculator, cosine 130 is negative 0.643. Okay, answering that, we will have 163.35 meters. Or if you're going to have first, let's have first the square. xz squared is equal to 26684.60 Getting the square root of both sides, and that would be xz is equal to 163.35 meters. This is now the distance of what? This is now the distance of the path from this to this, and that is equal to 163.35 meters. However, it says here, what distance is saved by walking along the path instead of going around? So if you're going to look at this, if this is going around the road, that would be around the road is equal to 100 plus 80, giving us 180 meters. However, if we're going to follow the path, path is 163.35 meters. Now, how much distance is saved? Okay, let's have your calculator. That would give us distance saved. So the distance saved would be around the road minus the path. And that would give us 180 minus 163.35, giving us 16.5 meters. This is the distance saved. Okay, next problem. There are two ships, one at P and the other at Q. Observations at the point R and shore determine that the ship at P is 22 kilometers from R and the ship at Q is 35 kilometers from R, and PRQ is 67 degrees. Say for example, we're going to draw, let's say this is the drawing. Let's say for example, this is P, this is Q, and this is R. It says here, we have to have this one first, P. Determine that the ship is here at P, 22 kilometers from R. Therefore, this is 22, because it says 22 kilometers from R. The ship at Q is 35 kilometers from R. From Q to R is 35 kilometers. So this is ship 1, this is ship 2. Okay, it says here, how far apart are the two ships? That would be from P to Q. This is now the distance of the two ships there. So how are we going to solve that? Again, we identify the sides. If that is R, then this would be R. Sorry, let's change that. So that would be R. That is P. Therefore, this is P. That is Q. Therefore, this is Q. So what is being asked? That would be P to Q, or this would be the distance R. So following the cosine law, that would give us R squared is equal to the other sides of the triangle. That would be P squared plus Q squared minus 2PQ cosine R. Okay, substituting the values in the formula, that would be P is equal to 35 squared plus Q, which is 22 squared, minus 2 times 35 times 22. And this is cosine. Oh, sorry, we did not place the angle here. That is supposed to be 67 degrees. Cosine 67. Getting your calculators, if you're going to solve that, this would now be 1107.274. However, this is again R squared. So getting the value of R, then we have 33.28 kilometers. So this is now the distance of the two ships.